Welcome back sa ato ang discussion. We'll continue on where we left off sa katong previous video. So the previous lecture we did fitting using least squares method, but it makes use of a linear equation only. Right? So ato ang fitting is done by employing this equation, y equals mx plus b. Or in general nga mga equation, it's usually mostly found in mathematical or mathematics books. It's like this. We have C naught plus C1x. Actually, parehara na siya. Okay. So this is a linear equation. So we have a constant and a one order. So that's actually x to the 1. So order 1 na siya. Okay. But there's actually a limitation for this if we use this equation, because good thing atong equation is follow siya og it's like just by seeing at it uh, equation sa line, right? Straight lines here, but not all data that we can get from an experiment will look like this. Okay, will behave like a straight line. How about if parabolic here? Okay, so we can extend this one. So, but can we? So can we extend our knowledge from here instead of a linear fit? How about a quadratic fit or a cubic fit or or generally a polynomial equation? Okay, so luckily we can do that. We have these general least squares. So this is an extension of our knowledge in the previous lecture, that is line naman to siya. So this is the equation or the polynomial equation of degree m. Okay, this is a polynomial equation of degree m. Okay, kani siya. So general na siya nga equation. So notice nga mo na siya ato ang uh, previous nga gigamit equation of a line. We have C naught and C1x. Right? This is your mxb and this is your a, right? So extending that one not only sa linear, which is of order 1, we can have order 2 parabolic, order 3 cubic, and so on, up to x to the m generally. So to make a best fit out of this polynomial, the same method gihapon ang gigamit sa previous, which is you get the sum of error. Okay? This time, this is general equation na siya. Right? Di na siya line of a polynomial, which is this. Mao na siya. Alright, mao na. And let's say if we want to determine the best fit or the best curve for this polynomial, then we have to make sure nga ang iyang sum sa error ana niya, that should be minimum. So if you have an equation of your curve with you, nga naay mga constants from C0, C1, C2, and so on, then you need to determine those constant in such a way nga minimum ang iyahang sum. Okay, ang iyang sum sa sum sa squares or least squares that siya dapat. So the same method gihapon itong gigamit last time. Okay, so we require that S over kana siya, I runs from 0 up to M should be 0. So it should be at the minimum. For an equation of a line, duha naman ang constant, di ba? C0 and C1. So duha lang. But if you have quadratic na terms, so tulo na siya, that mo add na ang C2. If you have cubic, C3, and so on. Generally, you have C sub M. So if you have linear, ana naman na siya. C0 plus C1x, right? We have quadratic, Px we have quadratic. Oops, it's not working. So for quadratic, we have this. So take note nga sa linear natay duha ka unknown. So you will be needing two equations ani. In order for you to solve two unknowns, you need two equations to solve it simultaneously. For quadratic, you have three unknowns, you need three equations. So where you can get that three equations from this? Itong i-derivative nimo ang s with respect to c naught, to c1, and to c2 if quadratic siya. So that will give you these equations, right? So if you take the derivative of that, of each, you get this. Okay? Kana, if imo siyang i-derive. So you have that sets of equation. So let's say we have this another example wherein delete na mo, you have this equation with you. This is, ang data niya is time tapos height is like ang iyang graph is, it resembles that of a projectile motion, right? So naatay time nga data on the x-axis, and for each time naa siya gi-measure nga height of that projectile. Okay? So having this data, dako ang imuhang error gyud if mogamit pa ka og straight line, because definitely this cannot be fit using a straight line. So we need to do better than that, and that is by using quadratic formula. So magamit na ka og quadratic equation for this. So actually this will be part of your problem set wherein mag-fitting mo ana. So magamit mo ani nga equation. You have uh, c naught plus c1 plus c2x squared. Gamit mo ana. And then you have to determine c naught, c1, and c2. Unsa na siya? Para naamoy best kay nani man ni siya. Right? So inyohang dapat makakuha mo ani, it's a inani inyohang graph. This is your best fit. So to get that best fit nga equation, you need to determine the coefficients or constants c naught, c1, and c2. Okay? So you need three equations if you have three unknowns. So makuha na mo na siya using S, C naught, right? S, C1, and then S, C2 equals 0. And what is S? Anak naman na, di ba? Katong Px minus P, right? Square. Okay. So, kana lang. Then, you should be able to determine this one. Na kay data. You have your data with you, this one. And then, find the best fit for this type of data by using quadratic formula. Okay. So next is we move on to curve fitting using uh, MATLAB built-in routine. Okay. So curve fitting using MATLAB built-in function. So for this section, we'll make use of MATLAB's powerful own built-in function for curve fitting, and that is fit and fit type. So the good thing is nasabtan naman to nato ang the method of least squares, right? Actually, mo na siya ang idea nga nung unsa ni ang fit function all about and fit type. It makes use of the idea of the least squares method. That's why na-introduce na to daan ang idea of least squares because if you use fit, masabtan nimo siya nga nung where is this coming from ba nga nung work na siya successfully unsa yung mathematics or concept behind it. Okay, so we'll apply this fit function to our all data. Okay, so ito ning gamiton. The same Japan nga data itong gamiton, but we'll be using, instead of doing this, kani nga mga mag-determine sa matrix and so on, itong gamitan na to og fit na function. Okay, this is x2, sample 2. So we have our data na. So, ay function si MATLAB nga automatic nag-determine ang constants a and b, and that's what we call a fit function. So, sa fit nga function, we have fit, fit, and then accept siya og 3 ka arguments. Okay. We have t, and then v, and of course, unsa nga type of fitting. Linear man ni siya, di ba? Ito sa example, this is linear. So, we have poly 1 of order 1. If you want quadratic, then poly 2. If you have cubic, poly 3. Okay? And take note nga, ito na siya i-convert into, kaya ang i-accept man nga data sa imong fit nga function are actually column vectors. And we made this one as row. So, kailangan to siya imoong column. So, ato siya i-transpose into having this t prime and v prime. Okay? So, notice nga, inana lang siya, one line lang. And, giyon sa pag-implement, kani siya. Right? So, medyo taas-taas siya. Sa inyong assignment na yun, do not make use of this fit. Okay? Kanagya pa ninyong gamiton. Yung sa pag-implement ba, this is for poly 2, kung quadratic. Right? So, mausab na ni siya. This becomes 3 equations and so on. Okay, so going back ani. So the result for that is automatic na ihatag ang constants a and b. So ato na i-run x2. Right? So let's type f. So you have your fit function. Ang result is store niya sa object na f. Okay. Let's take a look at f. Ito na. So automatic na siya ba? Let's say this is your linear, this is actually, yes, linear because poly 1. Linear model, poly 1. And this is our equation. So the slope is stored in P1. That's slope P1. And ang y-intercept is P2 with a confidence interval of 95%. So this is actually the same, right? Sa katong nakuha natong result sa previous nga video. This is your y-intercept, the slope, which is the acceleration due to gravity. Right? So muna yung error naman siya of 95%. This is the minimum and maximum error. Okay. And then, P2 is your y-intercept. So, if you go back sa katong x1, ito i-calculate ang x1. So, actually the same. Oh, similar, right? Take a look at this, 10.9 and then 10.09 and so on. So, we can use this fit function. So, automatic na ihatag. And then, next is atoan ng i-plot ang empirical na itong data and the theoretical data using the fit function. Okay? So, mag-create og theoretical data. This is theoretical nga velocity. And then, we have, so to access the P1, magamit ta og dot operator. Okay? Okay. Ang F, nag-contain man siya og katong slope and the y-intercept. The P1 is the slope, tara. P2 is the y-intercept. So para ma-access na to ang P1, we have to have this dot operator because F is an object. So F dot P1 times T para maka-generate ang theoretical nga velocity and F dot P2. Right? And then we will plot. So we can make use of this type of plot. Hold on, katong kasi separate kapag plot. Pero mo superimpose gihapon. So plot the experimental data, t.v, and then let's say red, and that theoretical, t.vt, tapos black lang siya nga color nga line, straight line. Okay. After that, buhatag title para add og beauty sa to ang graph. The title would be, say, linear fit. AX plus B. And do the labeling. And then the legend. Okay, and then hold off. So this should give us the same graph or result sa katong example 1. But ang naka-advantage lang ani is usa na siya ka line, right? Instead of having this say 3 lines or 4 lines, that can be replaced by just employing one line. So one function. All right, it's the same result na nakuha. So it makes use of the fit function, and it really made our life easier, right? So ang fit function na siya tulo ka input. We have the x-axis, the y-axis, and then the fit type. So this is your fit type. You have poly 1, poly 2, and so on. So the complete documentation for that is given in mathworks.com. So tanawon nimo ang complete type of kasi klase nga fit type diha. You have uh, not just for linear and for quadratic, but in general. So in most of our calculation in the future, or even when you uh, even in the future nga magtrabaho na mo, we'll be using this kaning mas simple naman na siya fit function. So but why go through all those calculations before, like kaning, right? This is the fit function man, di ba? Ihang skeleton niya unsa yang sulod about. So why go through that? So that's an important task to do, because in that way you will have a solid understanding regarding how the fit function is implemented behind the scenes, and not just merely using it, right? So it's good to know what's the theory behind it. So we'll consider another example wherein we will be going to fit a data, but this time not using a linear function, but not na we'll be using a data wherein dili na siya polynomial nga type. Okay? So then we will generate a best fit based from the data. Okay? So na ako'y data daan nga available. So kaning data is stored in an Excel file. Ako maning i-upload sa Google Classroom later on. Okay? So let me have this. Let me open. Actually, nabuhat na ako na siya nga file. The data looks like this. Tara. So this is the data. You have your time and then experimental value. And then we can do a fitting for this data using linear, using quadratic, and using exponential. Or you can use another function of your own choice. So we already know how to do it using linear, right? Magamit ang matag fit function, poly 1. This one is fit function gihapon, poly 2. But this one is another function wherein dili siya polynomial. This is a specific function nga imong i-type. Okay? So, let me open the program akong gibuhat ani. Oh, it's actually okay. Oh, it's not dili mao. Ah, here. So in this program, it it will solve or try to generate a best fit for this data using linear, using quadratic, and the exponential fit. So if you take a look at the program, so kindly try to analyze na lang for this program line by line. Tapos in your own free time, you try to understand what I wrote here. Okay? So kani siya is condition naman na siya nga ang I made this program a function. Okay? So where n is from 1 up to 3. If i-input nimo ang 1, automatic ang ihatag nga result is for linear fit. If 2, then you have quadratic. And if it's 3, then it's exponential. So this one is i-make sure lang niya nga ang i-input niya is from 1 to 3. Okay? If dapat scalar siya, meaning single valued, dili pwede dili pwede ang input niya is matrix. A single value. Kaya n, yung mga input dili n, either 1, 2, or 3. And then, nako'y special dali nga command, which is XLS read. Okay, so i-read niya ang data, okay, from the Excel file. Okay, let's say this is the Excel file, example 4.4. Ang command is XLS read. So, i-store niya diha sa kaninga variable data, i-store niya ang imuhang data, all those numeric data. Say, for this case, i-store niya ang this one, the time, kani siya, and kana. Kana ra ang iyahang i-record ang katong naay mga numerical values. So from there, so ang data contains two columns. You have column 1 and column 2. So ang tanan data from the column 1, wala siya pasabot ana, tanan data from the column 1 is stored in the variable time, and ang tanan data from the column 2 is stored in the variable y. Okay? So after that, na condition. If n ang nag-input niya is 1, then ha. If 1, then I do this. Okay, that's a linear fit. Okay, fit. Have time, the y, and the poly 1. Tapos mo ni siya iyang theoretical data. And I plot the theoretical and the experimental in one graph para ma-compare. If n is equal to 2, meaning I want to find the best fit for quadratic. That's why poly 2 na siya. Then this is the equation for the quadratic. You have three constants, P1, P2, and P3. And this one is the most interesting, is the fit type. Okay? Okay, di naman mo gamit ang fit na function kay for polynomials naman na siya. This one is not polynomial anymore. So actually of your own choice ni siya. You have your fit type, then ako'y at sign, meaning it will take these functions for variables or parameters. You have constants A, B, and C. So if you take a look at this, yung constants is A, B, and C. right? Kani. And ang equation niya is given by that. You have a times e to the b times x plus c. And then, actually, fit, gihapon ang gamit ng function, right? Fit. But this time, instead na katong poly 1 or poly 2 ang third argument, it's actually my fit type given by this. It's just a variable name, my fit type. Then ako start point and you have your x naught. Okay? Your starting point is x naught, which is this. Unsa na yung starting point? Unsa na yung x naught? So so dapat na siya yung starting point, meaning unsa dapat initial value niya para mo run imong program. For x naught, this is the starting point, initial value sa A, sa B, and sa C. And then, yan na i-compute. Tapos, i-store niya ang value sa A, B, and C sa kanyang object F. Then, to access those constants, you have f.a, f.p, and then f.c. Then, i-plot tayo na niya. Okay? We'll try to look into sa result. Fit func, let's say linear 1. Okay. So, take a look at this. Your data is katong dash line, kaning red, right? And your fitting is linear man siya, so dili kay siya nindot. So poor ang iyang dili kay siya nice nga fitting, right? Kay technically, looking at it sa graph, it's not actually a line. So it would be too foolish for us to use equation of a line. Upon seeing it, di gid mo fit ang line ana, okay? So at least na determine niya unsa ang this is the best fit niya if line imong gamit. So this is the best equation of a line nga mo fit ani. But sadly, di gyapon siya mo fit because it's actually not a line. It's a quadratic. So we'll try to look into fit func 2. Na? Oh, so even the quadratic na line is actually nindot na ato ang kuan, di ba? Ang ihang actually good na ang ihang approximation. Okay. So for the quadratic, actually the result showed a promising result already. Okay. So it already gave us a very good fit of our experiment. So it turns out that a quadratic function will do just right as our mathematical model that will capture the behavior of our data. Now it's your turn to di na ko mo run ani ka mo na layran ana unsa kay ihang graph sa fit func 3. Okay, will it be better compared sa fit func 2 o sa quadratic compared sa exponential? So it's for you to find out. I-run ninyo na siya. Okay? And then I think that ends our discussion for this chapter, that is function approximation, particularly on the method of least squares in curve fitting. Okay? So if you have questions, you can feel free to ask me anytime. Mo reply ra jud ko through messenger, email, or you can comment down below sa YouTube na kaning video. Okay? That would be all. Thank you and stay safe mo tanan. God bless.